Hi everyone, this is Fahad Mirza and I welcome you to the channel. In this video, I am going to share with you a research project which I believe going to be a big thing very likely in the near future. Luma Labs' introduction of inductive moment matching, or IMM in short, represents an important advancement in generative AI that has been designed to overcome persistent inference time inefficiencies found in current generative modeling paradigms. And I have even seen that in top of the line generative model, so that is why I am very interested in this new development. So what exactly is the issue here in simple words, which this new IMM is trying to solve, is the topic of this video. Historically, Gen AI methods have been dominated by autoregressive models for discrete data like language and diffusion models for continuous data like images, videos, or audio, both of which face clear limitations. Diffusion models, in particular, require numerous iterative refinement steps that significantly hamper inference speed and model efficiency, limiting the full utilization of powerful multimodal datasets and hindering progress in developing comprehensive multimodal intelligence. IMM addresses these inherent inference time constraints by permitting greater flexibility at each sampling iteration. Unlike diffusion models, which interpolate linearly between consecutive timestamps and thereby restricting each inference step's expressiveness, this IMM explicitly processes both the current and future target timestamps simultaneously. That uses maximum mean discrepancy, which is a mature statistical moment matching approach to directly match the distribution of output towards that target step. And that is why I believe this might be a big thing very soon, because this subtle yet strategically significant modification allows the model to realize drastically improved efficiency and quality. In extensive benchmark, which they also have shared on their GitHub repo, and I will drop the link to it in video's description, IMM achieves substantially better freshet inception distance, or FID scores, while requiring up to 30 times fewer sampling steps. Also, IMM reaches state of the art results with just 2 sampling steps on Cypher 10, that showcases its unprecedented sampling efficiency and efficacy, and I have never seen that before. Now, perhaps most significantly, IMM represents an essential conceptual shift. By prioritizing inference time efficiency directly in the pre-training design choice, IMM reveals and addresses a hidden bottleneck present in current generative modeling paradigms. Its robustness across diverse hyperparameters and architectures, ease of implementation relative to consistency models, which have recently demonstrated unstable training dynamics, and freedom from reliance on score based frameworks, further cement IMM as a broadly applicable and practically attractive tool. IMMs, I would say, underlying concept open promising avenues for generative modeling to fully exploit increasingly rich multimodal datasets that paves the way towards significant advances in multimodal intelligence. So, in short, IMM not only redefines efficiency and quality standards in generative modeling, but also signals an exciting future shift away from entrenched diffusion based approaches towards newer, more versatile, and inherently more scalable architectures. I hope that they also open source everything around it, because I'm more than sure they will, because Stanford University is involved. So I'm very hopeful, or as they say in crypto lingo, I'm very bullish on this project. So let's see how it goes in the future. I'll be keeping my eye on it, and as soon as I get something concrete to show for it, I will create a local hands-on video on it. Before I let you go, let me also introduce you to the sponsors of the video, who are AgentBot, that lets you effortlessly deploy a personalized knowledge bot across platforms like Discord, Slack, and others. It is ideal for open source tech communities and startups that provide user support, and I will also drop the link to their website in video's description. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as it helps a lot. Thank you for watching.